Morning everyone, I am Shabina Fatma. Today we are going to discuss about NAA, that is Neutron Activation Analysis. So what is NAA? It is actually an analytical technique for the qualitative and quantitative analysis of trace elements. It is used for measuring the concentration of elements even in trace amounts. So this NAA, that is Neutron Activation Analysis, was discovered in 1936 by two scientists. They are Hevesi and Levy. And this neutron activation analysis, as the name suggests, neutron activation analysis, it is actually a nuclear process, and this process is non-destructive. The principle behind this technique is, in this technique, the neutron is bombarded on the target nucleus. Means there is bombardment of neutrons on target nucleus, and when the neutrons are bombarded, the target nucleus became excited, and when the nucleus becomes excited, they emit the gamma rays. So the rays which they emit, they are prompt gamma rays, and once they emit the gamma rays, they become radioactive. Means the non-radioactive compound is converted to radioactive compounds after emission of gamma rays, and once they become radioactive, they again emit the gamma rays and the beta particles. So the gamma particles which they emit after becoming radioactive are known as delayed gamma rays, and the beta particles is also emitted, and its emission is continuous. Its sensitivity is greater than that of gamma rays, and after their emission, it becomes stable. The nucleus becomes stable. So the gamma rays which was emitted in this procedure, the gamma rays are of two types. One is prompt gamma rays and another one is delayed gamma rays. So the prompt gamma rays, they are emitted they are emitted when the substance is non-radioactive, and the delayed gamma rays are emitted after the substance becomes radioactive. So NAA, that is neutron activation analysis, can be of two types. Prompt gamma rays neutron activation analysis, that is PGNAA, and another one is DGNAA, that is delayed gamma rays neutron activation analysis. So where they are used actually? So PGNAA, that is prompt gamma rays neutron activation analysis, it is used where the neutron capturing area is greater and where the radioactive nucleus is not formed, and where the long irradiation time delayed gamma rays neutron activation analysis is used. And the most speciality of this NAA is it is non-destructive technique, so it is used in historical artifacts. Now let's talk about the forms of NAA. One is RNAA, another one is INAA. RNAA means radiochemical neutron activation analysis, and INAA is instrumental neutron activation analysis. So this RNAA is destructive technique, because in this technique what happened, first the target nucleus is bombarded with neutron, then the compound nucleus undergoes the chemical modification and the interference molecules are removed and the required elements are gathered. But in INAA, that is instrumental neutron activation analysis, it is non-destructive. Means there is no modification after bombardment of neutron. The non-radioactive compound become radioactive compound and we can analyze the sample. Now, in neutron activation analysis, what we do? We do bombardment. Here bombardment of neutron is done. So we should know the sources of neutron in neutron activation analysis. So the nuclear reactor can act as the source for neutron, or the neutron reactor. And in neutron activation analysis, the incident neutron is bombarded on target nucleus, and then the compound nucleus emit the prompt gamma rays and becomes a radioactive nucleus, and after becoming radioactive nucleus they emit the decay gamma rays and the beta particle, and finally they get stable nucleus. So some of its advantages are, it is non-destructive technique and we can do the in-depth analysis and small sampling size is required. But some of its limitations are, it is time-taking process, and in case of carbon and oxygen, neutron activation analysis cannot be done. It is less common, and while we study about the sample, the structure and physical properties cannot be determined by NAA, only the qualitative and quantitative analysis can be done. And some of its applications are, it is used in forensic science, it is used in historical artifacts for elemental detection, it is used for checking the environmental pollutants. So friends, this is all about the neutron activation analysis, which is used for determining the concentration of elements even in trace amounts. It is used in forensics, in detection of poisons, in detection of metallic poisons, in hair examination for knowing the concentration of some of the poisons which deposit in hair or nails, like arsenic, mercuric, or any kind of metallic poison. So its significance is in forensics also. So friends, this is all about the neutron activation analysis. If you like the video, then please do like, share, comment and subscribe to my channel. Thank you. Have a good day. Jai Hind.